Okay, last class we finished up chapter 5, and to kind of review that on the inverse trig functions, I've put together a warm up here for you to try. So try these 6 values and then check your answers on these. Okay, on the first one, inverse sine of -3/2. So for inverse sine, we're going to go down here to the negative. We're going to go to the third quadrant. The fourth quadrant, and that's going to be negative square root of 3 over 2 is 5 pi over 3, but we don't write it as 5 pi over 3, we write it as negative pi over 3. Tangent is negative square root of 3 over 3 for the pi over 6's, and it's going to be negative in the fourth quadrant, so instead of 11 pi over 6, we're going to write it as negative pi over 6. For inverse cosine of -1, cosine is -1 here, so our answer is going to be pi. Inverse sine of 3, there's no place on the unit circle that sine is more than 1, so it's undefined. Here, this is between the negative pi over 2 and positive pi over 2, so since it's within that interval, we can cancel those. Same thing here, we can cancel those. Okay, today we're going to be looking at chapter 6, which is going to continue talking about trig functions, but specifically today we're going to be talking about angle measures. Okay, so an angle measure consists of 2 rays. So we have our initial side that's always going to be positioned here on the positive x-axis. And then we're going to have our second ray, which is going to be the terminal side. So we have the initial side and we have the terminal side with that. So we can have a positive angle that goes counterclockwise. We can have a negative angle that goes clockwise. And some of this is going to be review. So just kind of bear with me that we're going to go through a few things that you may already be familiar with. Okay, so we have the initial side and the terminal side and so forth. So the measure of an angle is the amount of rotation about the vertex to move R1 onto R2. And so we're going to start measuring in degrees for some of our problems. So this is where you really need to be careful with your calculator that you have it in the right mode. So some problems will require degree mode and some will require radian mode. Some will require you to go back and forth between the two. So just be really careful with that. So an angle of measure 1 degree is formed by rotating the side 1/360th of a complete revolution. So we know that to go all the way around a circle is 360 degrees. So if we go 1 degree of that is going to be 1/360th of the circle. So we can measure our angles in degrees. We can also measure them in radians. So what a radian is if we have a circle of radius 1, which is our unit circle, drawn with the vertex of an angle at its center, so we've got this vertex here located at the center of the circle, then the measure of this angle in radians, so the measure of this angle in radians is the length of the arc that subtends the angle. So subtends means we have this arc out here and it's going to be intersecting this angle here. So this is the arc that subtends this angle with that. So the length of this arc is our radian measure for theta. So theta is measured in degrees, but the radian measure around the outside edge of the unit circle is going to be the radian for that. Okay, so you know that to go all the way around a circle is 2 pi, which is approximately 6.28. So basically what that means is if I were to take one radius and lay it around the unit circle, then 6 and a little over a quarter of those, it would take a little more than 6 1/4 radiuses to go around this unit circle. Okay, so 1 radian is going to be here because up here at the top is pi over 2. That's approximately 1.57. Pi radians puts us over here. Pi over 2 radians puts us here. 2 radians, we're going to stop somewhere in the second quadrant. Okay, so we need to be able to go back and forth between the two. So 180 degrees is equal to 1 pi radian. Okay, 1 radian is 180 degrees divided by pi. Okay, and 1 degree is pi over 180. So basically, these are the rules you need to know. If you're going from degrees to radians, you multiply by pi over 180. If you're going from radians to degrees, you multiply by 180 over pi. So here I've got 60 degrees. So I'm going from degrees to radians. So I'm going to multiply that by pi over 180. So that's going to be 60 over 180 times pi. 60 over 180 is 1/3. Or we could write that as pi over 3. Okay, here I'm going to go from radians to degrees. So I'm going to multiply that by 180 over pi. My pi's will cancel. We're going to simplify this, and that's going to be 30 degrees. Okay, here's 2 for you to practice on. Okay, so 75, if you're converting it to radians, multiply it by pi over 180. So this is going to simplify to the fraction 5/12. So we'll have 5/12 pi. We start with 5 pi over 3 and multiply it by 180 over pi to convert it to degrees. The pi's will cancel. That's going to give us 900 degrees over 3, which is 300. Okay, so a couple of things to keep in mind. We'll say a 30-degree angle, and that's the same thing as an angle whose measures 30 degrees. So depending on whether you are measuring in degrees or radians, 30 degrees is equivalent to pi over 6 radians. So we'll go back and forth between the two. If no unit is specified, then you're going to assume it's measured in radians. And this is where, again, you need to be careful your calculator's in the correct mode. Okay, we have our standard position. So standard position is always going to start from this positive x-axis. So that's our initial ray. So that's our starting position. We have a positive angle. We're going to move counterclockwise. If we have a negative angle, we're going to move clockwise and so forth. So we can have multiple angles that have the same terminal side there. Okay, coterminal angles basically just mean they have the same terminal side. So this would be a coterminal angle to the one that goes all the way around and ends up back in the same place as well. So both of these are coterminal angles. If you're asked to find angles that are coterminal with the 30 degrees, we can do that. If you're talking about degrees, you can simply add 360 if you need to get positive angles. And you could keep doing that as many times as you needed to. So if I add, sorry, not 30, if I add 360 again, then I'm going to have 750. If I wanted negative coterminal angles, then I could do 30 degrees minus 360 would be negative 330. If I did negative 330 minus 360, I'm going to have negative 690. So it depends on if it's asking for positive coterminal angles or negative coterminal angles. And I could keep going. I could keep adding 360. I could keep subtracting 360. And so all of these are going to be coterminal angles. Same thing with the pi over 3, except instead of adding 360, we're going to add and subtract 2 pi to our answers. So if we look at this one here, if I take pi over 3 and add 2 pi to it, what I would suggest doing is to do this on your calculator unless you're really good with fractions. Take the pi's out, like forget that they're there, which means you're going to add 1/3 and 2 together. If I add 1/3 and 2 together, that gives me 7/3, and then just the pi beside it because it's still going to be there. If I take 7 pi over 3 and add 2 to it, I'm going to do the same thing. I'm going to factor that pi out the back side of that parenthesis, which leaves me with 7/3 plus 2, and then combine those together and I get 13/3 and then put the pi beside that. So if I continue to add 2 pi, get coterminal angles. Same thing with subtracting 2 pi. I'm going to get coterminal that way as well. So I'll take out pi, and I'm going to have 1/3 minus 2. 1/3 minus 2 is negative 5/3. If I have negative 5 pi over 3 minus 2 pi, take the pi out the back, do negative 5/3 minus 2, convert that to your fraction, and then you'll have this answer. WebAssign is not going to want the decimal answer for this, so it's going to want 7/3 with the pi written beside it, because this would be an exact answer, and that's usually what WebAssign is going to ask for. Okay, so this is just showing you the 30-degree angle, the 390-degree angle, and the negative 330-degree angle all look exactly the same as far as their position on the coordinate plane there. Same thing with these pi over 3s. So pi over 3, 7 pi over 3, and negative 5 pi over 3 all end up at the same location as well. Okay, another thing included in this section is talking about lengths of a circular arc. So we have a formula here, S equals R theta. And so S is the arc length. R is our radius. And theta is our central angle that must be in radians. So you see this warning here, theta must be in radians in order for this to work. So if theta is given to you in degrees, then you have to use the conversion formula to convert it from degrees to radians before you can use this formula. Another version of this, if we were to divide both sides by r, then we get theta equals S over r, and so we get this formula here. Okay. All right, so part A, find the length of an arc of a circle with radius 10 that subtends a central angle of 30 degrees. Okay, so here's our circle. We've got our 30-degree angle. We're needing to find this arc length here, which is S, and we have a radius of 10. So we know that S equals R theta. Our radius is 10, and theta is 30 degrees, but we need this in terms of radians. So I'm going to do 30 degrees times pi over 180. Okay, so that's going to be 30 over 180 times pi, which is going to be 1/6 pi, or pi over 6. So in the place of theta, we're going to put in pi over 6. So our answer, if we simplify this, 10/6 is going to be 5/3, so 5 pi over 3. So this was answer A. Okay, part B, a central angle theta in a circle of radius 4 is subtended by an arc of length 6 meters. Okay, so we have an arc that is 6, and this is our theta. We have a radius of 4. So I don't like to learn new formulas, so I'm just going to go back to my S equals R theta. This time my radius is 4. My theta is what I'm trying to find. My S is 6. So theta is going to be 6 over 4, or 3 over 2 radians. So my answer that I get out of this formula, if I'm solving for theta, is already in terms of radians. Okay, we can also find the area of a circular sector. So area for our circular sector is 1/2 r squared theta. So we're basically talking about some type of sector here. So if I wanted to find the area of this whole thing, then I could find that by doing 1/2 r squared theta. Again, theta has to be in terms of radians. Okay, so we've got area equals 1/2 r squared theta. So we have a central angle of 60 degrees. So I need to convert that to radians, which is going to be pi over 3. and we have a radius of 3. So my area is going to be 1/2 3 squared times pi over 3. So one of our 3's is going to cancel, so we're going to have 3 pi over 2 for our answer. And we don't need to forget our units. Our radius is in terms of meters, so this would be meters squared for our area. Okay, so linear speed is also important, and linear speed is the rate at which the distance traveled is changing. So in this case, we're talking about moving around the outside. We'll just take the total distance that you travel around the outside, divide it by the time, and that's going to give the linear speed. So linear speed is actually going to take into account the radius, because if our radius is larger, go all the way around the circle, we're going to travel more distance. So the radius will take Linear speed will take into account the radius, and then angular speed, which we're going to talk about in a minute, does not. So angular speed is the distance divided by the time, but instead of looking at how much it's changing as we go around this outside edge, we're looking at how much our angle is changing. So the radius itself is not important with angular speed. Theta must be in terms of radians in order to do this calculation. It cannot be in terms of degrees. So angular speed is the rate at which the central angle is changing. So angular speed is the number of radians the angle changes divided by the time that's elapsed. So again, linear speed does not take into account the radius, but angular speed does. Okay, so we've got a couple formulas here. We've got that angular speed is theta divided by time, and linear speed is the arc length divided by time, or we know that arc length is r times theta. So if I factor out the r, then theta over t is my angular speed. So the linear speed is your radius times your angular speed. So here we have a boy rotates a stone in a 3-foot long sling at the rate of 15 revolutions every 10 seconds. Find the angular and the linear velocities of the stone. So if we look at this, okay, we've got our angular speed is our theta divided by our time. So we know the time is pretty easy. The time is 10 seconds. And here, if we think about this, we've got this boy standing in the middle, and he's got a 3-foot long sling, and he's going around this 15 times. Okay, so if he goes around it 15 times, when you're looking at angular speed, he's going 15 revolutions every 10 seconds. So it's going to be, okay, in theta in terms of radians, every time he goes around, it's 2 pi. So each revolution is 2 pi, and he does that 15 times. So 15 times 2 pi for each revolution is going to be 30 pi. So here, my angular speed is 30 pi divided by 10. This is in terms of radians. So that's going to be 3 pi radians per second. That's my angular speed. My linear velocity is going to be the radius times that angular speed. So my radius was 3, and my angular speed is 3 pi. So that's going to give me 9 pi feet per second. Okay, if you want to go through further and look at the explanation, you can. Okay, so we have an example here. A woman is riding a bicycle whose wheels are 26 inches in diameter. Okay, so here's the wheel of one of the bicycles. It's 26 inches in diameter, which means the radius is 13 inches. If the wheels rotate at 125 revolutions per minute, we want to find the speed at which she is traveling. Okay, So the speed is going to be our linear velocity. So to find our linear velocity, that's our radius times our theta. Actually, sorry, our radius times our angular speed. So our radius in this case was 13 inches, and our angular speed is theta divided by time. Okay, so the revolutions are going 125 revolutions per minute. So that's going to be 125 times 2 pi. So 250 pi is how far our angular speed is, our theta is, and our 250 pi, and that's per minute. So we're going to then come over here and put in 250 pi per minute. So when we calculate that, we get 3,250 pi inches per minute. Okay, we want it in miles per hour. So we're going to need to do a couple conversions. We know that there's 60 minutes in 1 hour. We also know that there are 12 inches in 1 foot. There are 5,280 feet in 1 mile. So if we convert all of this, then we're going to get it in the right units. Plot all of this out and cancel all the like factors. We'll cancel our feet, cancel our inches. We're going to have 3.077 pi. So if we multiply that out, we get 9.7, and that's going to be in miles per hour. So just to recap on this, there's kind of a lot going on. Our linear velocity, which is what we ultimately need to find here, is going to be our radius times our angular speed. So our radius is 13, and our angular speed we find over here. So for angular speed, we need to look at how many revolutions. So it's 125 times around, and each time around is 2 pi. So this is where we get the 250 pi from that goes in for theta. And that is per minute. So this is like 1 minute that's in the denominator. So this ratio then is going to represent our angular speed, and that goes in here in the place of the angular speed. If we multiply that out, then we get 3,250 pi inches per minute. The rest is just is conversion factors. We need to get it all the way to miles per hour. So if I convert minutes to hours, 60 minutes in 1 hour, and then convert inches to feet, 12 inches in 1 foot, and then convert feet to miles, 5,280 feet in 1 mile. Multiply all that out, and you get 9.7 miles per hour. Okay, that takes us to the end of this section, and let me know if you have any questions. I hope you have a good day.